Today I'm going to talk about CDK, that stands for CloudFormation Cloud Development Kit. Okay, I'm going to talk about what it is, how it works, and some comparative with other infrastructure as code tools. And this is the first part of the session, and then I'm going to explain how we use it in set code and how we implement it. So a brief introduction. CDK is a software development framework to define infrastructure. We use code to define this infrastructure. It is built on top of AWS CloudFormation, so it's only deployable to AWS. I'm going to explain a little bit later about CloudFormation. And then, well, as other infrastructure as code tools, well, it has speed and simplicity that allows you to spin up an entire infrastructure by just running a script. We also configuration consistency. That means that having all the infrastructure, all the environments with the same code means that it will have the same behavior in all the environments. So they can have the same setup, maybe different parameters, but the behavior between the environments should be the same. Infrastructure documentation. Well, you can have all the knowledge of the infrastructure documented because it's code. So you can also can have it as in control version, and to have to track every infrastructure change. Then cost savings. Well, automating the infrastructure infrastructure deployments allows engineers to spend less time in performing manual work. So you can spend this time to execute higher value tasks. As I mentioned earlier, the infrastructure as code script can automatically spin up or spin down environments, so you can destroy all the environment and that is not in use in that moment. For example, a development environment, and that will save on cloud computing costs. One of the main advantages of CDK is that support different programming languages. You can use TypeScript, JavaScript, Java, .NET, or Python. To understand CDK, we need to understand a little bit about how CloudFormation works, because it uses CloudFormation to develop to deploy all the infrastructure. So some key concepts of CloudFormation is also an infrastructure as code tool. It's based on templates, JSON or YAML template files, where you define all your resources, all AWS resources. Then we have the stacks that are some resources logically related. You put in the same stack, so you can deploy as a single unit. Call it a stack. Maybe you can relate some database with EC2 instance or some other AWS services, and then deploy it as a single unit. This is the stack. Then we have the change sets. That is the changes that CloudFormation, reading the template file, will deploy, will change in your AWS account. And this is the workflow on the bottom of the slide. The first step would be changing your template file, your YAML or JSON template file, and then store it save it in a S3 bucket or even locally, and then submitting this template to CloudFormation, and it will give you these change sets that if you can review the changes before applying, and if you are happy with these changes, you can apply these changes, and CloudFormation will deploy all these changes that you already made. This is an example of a template file, a CloudFormation template file. Actually, it's the same template file because I didn't fit in the same slide. The left screenshot should go on top of the right one. There are some. The most important part is you can see my pointer. Yes. Okay. We have this is the most important part of a template file that we are defining here. The resources, the AWS resources. Basically, here we are creating an EC2 instance or a server with an image ID taken from this mapping. So in this mapping, depending on the region, this is something native from CloudFormation that gives you the region. Based on this region, you can get a different API. So it depends if in every region will have a different APIs. And then we have the instance type based on some conditionals and some parameters. The parameters are inputs that you can pass to the stack before deploying it. In this example, we are specifying the environment. So when you apply a stack, you can say, okay, this is my stack of test or devel or production. And based on that, we are creating for production environment, we are creating an EC2 instance with more memory and more CPU. And in the developer environment, it will be smaller. Then we are creating a new volume to be attached to this EC2 instance. Okay, this is an example of a template file written in a YAML format. So if CloudFormation is already an infrastructure as code tool that can deploy AWS infrastructure, why do we need another infrastructure as code tool on top of CloudFormation? So basically, because of these points. One of the main points would be that you can choose your programming language that you prefer. You can CDK leverage the power of imperative languages, so you can use loops, functions, conditionals, classes, whatever you can imagine. In CloudFormation, it's a plain YAML or JSON template, so you cannot use this kind of statements or functions or whatever. Code completion within your IDE. Also, it allows us to test our code. CDK has using your fabric framework of your language, you can test your code. And finally, CDK provides you some libraries, some constructs. I'm going to explain later this part, but basically it allows you to write less code and doing more things. This is a small comparative between CDK and Terraform. Terraform is one of the most famous infrastructure as code tool, and I'm comparing it with CDK. When AWS release a new feature, CDK needs to wait for CloudFormation because it uses CloudFormation. Usually it's short time to have this support, and in Terraform you need to wait for Terraform to develop this feature. License and support. Both tools are open source. CDK is supported by AWS, and Terraform is supported by HashiCorp, and already have a large community. Even if CDK it's a community that is growing so fast. The languages, I already mentioned it. You can use these languages, and Terraform uses a specific language, a declarative language, called HCL, developed by HashiCorp. Modularization, CDK uses your programming language you prefer. You can modularize your application, and Terraform uses some specific Terraform modules that they provide you. The state management, it's how the tool manages how the infrastructure is already deployed by your code. So CDK uses CloudFormation using a stack, so you can know in every moment the state of your infrastructure using CloudFormation. And Terraform uses a JSON that you can store in S3 or a document in DynamoDB, or you can use Terraform Cloud. Change management, so how the tool manages the changes between infrastructure and your code. With CDK, we have CDK diff that compares the desired state against the stack instead of already deployed infrastructure. And then while Terraform plan, you can see directly your changes between your infrastructure and your code. And CDK has a feature to roll back your changes if something goes wrong. Terraform doesn't have this feature. And regarding multi-cloud management, Terraform has many cloud providers, not only for infrastructure, but also other type of clouds. I don't know, GitHub, GitLab, or any kind of cloud providers. Okay, some concepts going deeper in CDK. We have constructs, stacks, and applications, an app. So with these three concepts, you can build a CDK application. We have inside the constructs, you can define some CDK provides you some constructs, some already built-in constructs, and you can also create some custom constructs. Inside the CDK constructs, there are 3 levels of constructs. There are the low-level constructs that always starts with CFN, that stands for CloudFormation. So when the class starts with CFN, means that it's a class that represents a CloudFormation resource. So if you remember, well, you remember in this template, for every resource, this would be our one resource, another resource, and another resource. And for the resource, we would have a class that represents this resource. Okay. Then we have the second level constructs that also represents a CloudFormation resource, but you can they have some attributes and methods that add functionality to the resource. So it's even if they represent as a CloudFormation resource, you have more capabilities in every class. And then we have the high-level constructs, also called patterns, that represents many CloudFormation resources. I put this example. The class application load balancer target service is creating in a single class, creating multiple AWS resources. In this example, I think they implement an application load balancer, a target group attached to this load balancer, also a ECS target service, a task definition deployed in this target service, and also an IAM role for this service. So in just one class and just one line of code, you can have all this infrastructure to run an application. Okay, and then we have custom constructs that you can customize. You can create your own constructs, and you can put all the constructs, all the CDK constructs inside it. So you can create some high level constructs like a pattern, but it's a custom construct. You can even put some high level constructs, some pattern inside your custom construct. Then we have the stacks that represents a CloudFormation stack that I explained before, and you can put a set of constructs inside a stack. Finally, we have the app, which defines a set of stacks. So you have application, you define stacks, and inside every stack you can define different constructs. This is a diagram representing what I've been explaining until now about CDK. You have the application written in the language you prefer, and then we are defining two stacks, 1 and 2. Inside every stack, we are creating different constructs that, they are custom constructs. Okay, and inside every custom construct, we will create some CDK constructs. It would be low level, would be second level, or even high level constructs. When we are ready, when we are happy with our code, we submit this the code to CloudFormation, so it will generate for every stack a CloudFormation template file, and then the CloudFormation will give you the change set to see the changes that CloudFormation wants to apply to AWS, and then apply these changes to your AWS account for you. This is an example of custom construct. We are defining a class called notifying bucket that extends from construct, and basically we are defining two second level constructs. One is a bucket and another is a topic, SNS topic, and we are taking advantages of the second level construct to use a method that allows us to notify to SNS topic when some events happen in the S3 bucket. Okay. Then we have the stacks and the application. We are creating a stack called Hello CDK stack that extends from stack. Well, this code is TypeScript, but it's quite straightforward. It's more or less the same in the rest of the programming languages. Basically, in this stack, we're creating an S3 bucket. So inside the stack, we are just using a level 2 construct, but here we can put whatever we like. We could even add here the custom construct that so this custom construct could be inside here. So we would create an S3 and SNS topic in this stack, just calling the custom construct. Then we are creating the application, and we call this stack, passing the application as an argument. Some comments of CDK that are the most important comments. CDK init a new empty CDK project. You can specify here the language that you are going to use in this command, and it will create the scaffolding of your application. Then we have CDK ls that lists the stacks that you have on your application. CDK synth that synthesizes and prints the CloudFormation template in JSON format, or even in YAML format. I think the YAML is the default. CDK diff that compares the code that you change it with the stack in your in CloudFormation, and gives you a change set about the changes that CloudFormation wants to deploy. And then we have CDK deploy to deploy this stack, or CDK destroy. You can specify with these 4 commands, synth, diff, deploy, or destroy. You can specify a specific stack, or you can, if you can put all the. If you don't put anything, it will be applied to all the stacks. Okay, I'm going to show you a demo. I'm going to share. I think I have to stop sharing this, and I will share. Okay, can you see my screen? Yeah. This is. I want to show you an example of CloudFormation template against the code of CDK. This is a template file written in YAML format. We're creating in this YAML. We're creating a VPC. We're creating all the networking to run an application, to run an ECS application. Okay, so we are creating firstly the VPC, the subnets, root tables. Here we're creating the task definition of the ECS service. We're creating also the ECS service, attaching this task definition. We're creating the target group of the load balancer, the load balancer rule. Well, this is the template file that creates all of this. Okay, and if we wanted to write it in CDK, it would be just this piece of code. We are defining a VPC that is creating a VPC and also all the subnets. we are creating the ECS cluster, and we are creating the application load balancer target service that will create the service, the application load balancer, and the target group. Okay, let's close this. So I have this empty directory, this empty project. The first thing I'm going to execute is a CDK init to initialize the application. I'm going to specify the language. In this case, I'm going to use Java. And if I don't put anything, it will create the scaffolding of the application. But for this example, I'm going to use some sample that CDK already provides you to do a test. Okay. So this will create the files needed for this and the code, and it's already using Maven. It's already compiling this application. Okay. We have already the source code here. So it's just a sample. It's creating a stack in this application. The application that is defined here. We are creating this stack and then passing the application to that stack. And then in the stack, we are creating SQS, an SQS queue, and a topic, an SNS topic. Okay, and then we are going to subscribe this SQS queue to this topic. Okay. So well, we can. Yeah, one thing I'm going to do is to specify a region where we are going to deploy this infrastructure. For example, I don't know, US West 2. And then, well, with CDK LS, we can see the stacks that we have in our code. So if we see is this a stack? So if we had here more stacks, will be shown here. Then we can do CDK synth to see the template file. So as you see here, this is the YAML template file defining all these three resources. Just with few lines, these few lines is creating all this template file. Okay, and this is the conditions and the conditionals depending on the region, etc. I'm going to. Then, well, we can do CDK diff to see the changes that CloudFormation wants to deploy, and we see here the change set. Okay, so it will create a queue, SQS, an SQS policy, and a topic, SNS topic, and SNS subscription. Okay, so we can do already deploy. Say yes. And this is going to create the stack first, and then create the resources in AWS. While it's creating it, I think I can show you this region where I created my stack. It's already here, and the resources that has created are here. So if we go to the SQS service, we can see the already created queue. This is the name of the default name that CDK gives you. You can customize the names. And then, well, we have the permissions that CDK already put in this request, and then we can go to SNS to see the topic and the description to this SQS. Okay, we are here. We have here the queue already created. Okay. Then back to CloudFormation, we can see if we go to this stack, we can see the template that we already saw in the terminal. The change set CDK already give us in the terminal also. Well, this is from CloudFormation, but you can have, if you have a critical stack, you can use this feature to enable termination protection. So if someone accidentally wants to destroy a critical stack, it would be denied. And you can use drift to detect if this stack is on sync or not between your code or your stack or and against the AWS infrastructure. Okay, then, well, we can destroy this. We can do it from here. We can do it also by CDK. If we put CDK destroy, well, it's the same. We can destroy it from here.